Welcome back. We'll go through some examples of factorisation. Remember, this is going the opposite way from expansion. A good reminder here would be that the two terms in the brackets will have to add to this middle term here with the x, and it will also have to multiply in order to get this constant number here. At times this will be quite fidgety since it will require playing around with the numbers a bit to see what fits both criteria. Let's get started. So for this one, we know that the numbers will have to add to 3, and they'll have to multiply to get 2. The easiest way of getting all the possible numbers would be to look at the factors of the constant. What are two numbers that multiply to get 2? In this case it's pretty simple because only 1 times 2, since 2 is a prime number. And then what numbers will add to get 3? That's just 1 plus 2. Right? We can see here that 1 and 2 do in fact satisfy this with a factorized expression. This simply just x plus 1 times x plus 2. Let's do a slightly trickier one. What if I have x squared plus 7x plus 10? So starting off, constant as 10. Now what are the factors of 10? 10 times 1, or it could be 5 times 2. Now the x value is 7. And remember, two values being multiplied to get 10 also have to add to 7. So we choose from here. 10 plus 1 will equal 11. So that's wrong. We know the next option is 5 plus 2, which is 7. And that's correct. This expression can be factorized to x plus 5 times x plus 2. So it's 5, it's 2, together to get 7, and we also multiply together to get 10. Now, would we double check if this factorized expression we have here is actually correct? Well, we can simply expand it again, right? As x squared plus x times 2, 2x plus 5x plus 5 times 2, 10. And this just becomes x squared plus 7x plus 10. And this matches what we had before, so we know that this is correct. Let's do something a little more tricky. Notice we have a negative sign over here for question 3 and 2 negative signs for question 4. These two examples I chose to fully illustrate differences between using the numbers. For question 3, know that the two terms have to multiply to get negative 8. 8 times negative 1, negative 8 times positive 1 is also negative 8. Remember, the combination you choose also has to add to this. For that we have 7x. Now how do we get 7x? Well, that's just positive 8 minus 1, because negative 8 plus 1 will be negative 7. So from this we know that the numbers have to be x plus 8 times x minus 1. And you expand this, which I encourage you to do, double check, then we will get this expanded form here. So for question 4, constant is the same again. So it could be times negative 1 or negative 8 times 1 again. But other options could multiply to 8, 2 and 4, or minus 2 and positive 4. We know that one number here must be negative. We were safe with going with 8 with our first choice here. 4 and 4 is 2x here and minus 8. I have to play around a bit with the numbers, trying to get these two numbers to add to this middle term here. And we know that it's this set because there's no way that this set can possibly get minus 2, because 8 minus 1, 7, and minus 8, 1, 7. So we know it has to be from this one. X term minus 2 and 4. It's just positive 2. Or we can have 2 plus minus 4, negative 2. And this combination adds to get this, right? Then we know that the numbers must be 2 and negative 4. 2 and negative 4, they multiply to get negative 8 as well. And 2 and negative 4 also add to get negative 2. For we have x 2 and x minus 4, and that's done. Now for our last example, we have a 2 in front of the x squared term. How do we deal with this? So from previous examples we know that x and the x squared was just this times this. Just the same principle, but we have to put a 2 in front of one of the x's, so that 2x multiplied by x will become 2x. So 20 can be 20 times 1 or 10 times 2, and the last one could be 5 times 4. Remember, combination we choose, we'll have to add to get this term here. So 12, and we know that it's positive 20. 10 plus 2 is 12, and so 2x plus 10 plus 2. Actually, let's do another example. This example also has a positive 20 here. We know the possible combinations are 20 and 1, 10 and 2. 5, and 4. Remember to always check this term here. And it's negative. And two negative numbers multiplied together will give you a positive number. We need to make sure that they multiply to 20 and also add -9. So minus 20 times minus 1 is positive 20, but if you add them together, it's minus 21, which is not correct. So we have the next option, negative 10 minus 2 is just minus 12. Next one we have minus 5 minus 4 minus 9, and that is correct. So now we know that the factored form will be x minus 5 and x minus 4. And again, we can always double check with the expanded form, and it will be correct. I hope this tutorial and these worked examples made sense. As always, thanks for watching, and if you found this helpful, please give it a like, share, and subscribe. And until next time, I'll see you. Oh yeah, for number 5, I realized that my answer is actually incorrect, because we can check by expanding. 2x squared plus 4x plus 10x plus 20, and then that's 2x squared plus 14x plus 20, and this 14x does not match with this 12x, so that's wrong. I guess this highlights how important double checking is, because it did come in handy here. So let's give that one another try, shall we? Okay, so second attempt. If you look closely, this entire thing can be simplified. So we have 2, 12, and 20. And the highest common factor among these is 2. So we can treat this like in the last video of simple factorization. 2 multiplied by x squared plus 6x plus 10, and then we look at factorizing this here. So x squared plus 6x plus 10, and I can say that we can't factorize this because if we look at 10, we have 10 or 1 multiplies into it, and another combination is 5 and 2. None of these add to get 6. So what we do is we simply stop here. I guess this example is a great one to show that sometimes we have cases where they can't be factorized.